Alakazam, Walakazoo. Ha, you didn't see my chin that time. Okay, this problem is from the Art of Problem Solving. Sorry, it's from the American Mathematics Competitions Proficiency Volume Dose. Okay, here's the problem. Let S of n and P of n denote the sum and product, respectively, of the digits of the integer n. For example, P of 23 is equal to 6. Now this is because P denotes product, and 23 would be the product of the digits of n. When 23 is n, it would be 2 times 3, which is equal to 6. And S of 23 is equal to 5. This is because S refers back to sum, and 23 would be the sum of the digits of n, or sum of 23 of the digits of 23. So we have 2 plus 3, which is equal to 5. Suppose that n, capital N this time, is a 2-digit number, such that n is equal to 3 of P of n plus S of n. How many values of n are there? Okay, so the first thing I'm going to do is I'm going to define n in terms of that 2-digit number it is. So I'm going to say n is equal to 10a plus b, where a and b are both numbers 1 through 9. So for example, if a is equal to 3 and b is equal to 5, the number would be 3 times 10, which is 30, plus 5, so the number would be 35. Now there's another thing I know, which is what it tells me. It says n is equal to 3 P of n plus S of n. Now I can rewrite P of n and S of n in terms of a and b. So P of n would be the digits times themselves. So if a is the first digit, or the tens place digit, and b is the ones place digit, it would be a times b. So I'm going to rewrite this as 3ab plus, and now S of n is going to be the 2 digits, the tens place digit and the ones place digit, added up together, so it's going to be a plus b. Okay, so now I have this and this. I'm going to use this, put them together, and try and solve for some stuff. So 10a plus b is equal to 3ab plus a plus b. And I can go ahead and erase this. So now these b's cancel out. I am left with 10a is equal to 3ab plus a. So that means that 9a is equal to 3ab. Now dividing by 3 on both sides, I get 3a is equal to ab. And now if I divide by a, I get b is equal to 3. Now be careful, when I divide by a, that means that a cannot be 0 because you cannot divide by 0, it's undefined. So I'm going to write up here, a is not equal to 0. Okay, now we know one of the numbers a can't be, that's going to count for something. And then we also know that b is equal to 3. So the ones place digit is going to always be equal to 3. So now all I have to do is plug this back in to this original equation, and we'll plug in b to this equation up here, and we'll see what we get for a. So I would say 10a plus 3 is equal to 3ab. Now 3ab is going to be 3a times b, so it's going to be 9a plus a plus 3. So we are left with 10a, and these 3's cancel out. You're left with 10a is equal to 10a. Now that works for any value of a because it's the same thing on both sides. And we also know that a cannot be 0, and from here we can solve the equation. So a can be any number 1 through 9 when it's integers 1 through 9. So all the numbers that it can be is a can be 1, b can be 3, a can be 2, b can be 3, on and on and on like this. 43 all the way up to 93. Those are all the possible numbers that fit the equation given above. Thank you very much for watching, and goodbye.